Okay, let's find the sum of each of these, and we're down here about halfway down on the front side of the paper. And if we're going to find the sum of these, first of all, we need to decide if they are arithmetic or geometric. So real quick in the calculator, we're going to experiment. Some of this can happen in your head, but for demonstration purposes, this is what we're going to do. All right. Here we go. Here's what we're going to do. We need to decide if this is arithmetic or geometric, so we're going to do 192 minus 128, which tells us that we added 64 to go from the first term to the second term. If 192 plus 64 gives us the next one, then dang, it doesn't. And because it doesn't, therefore, it is not arithmetic. So here we go, geometric. 192 divided by 128 is 1.5. Alright, so 192 times 1.5 should give us the next one. If it does, yay, good. And if we wanted to, we could keep going, times 1.5, excuse me, times 1.5, times 1.5, times 1.5, times 1.5, times 1.5, there we go. Oh wow, we got to that very last number right there. That's going to come in handy in a minute. Tuck that away in the back of your mind. We are adding a sum of a geometric sequence. So the question is this finite or infinite? Now we've not talked about infinite yet, and I'll go ahead and tell you we're not going to get to those quite yet, but I want to go ahead and point out the things to look for. This sequence ends. It stops right there at that one. Because it stops, it is a finite series, and here is your formula, a1 minus r to the n over 1 minus r, put it in parentheses for fun and for consistency. And so what we need to do is fill in the numbers. So here's the easy part. We know what A1 is. 128. 1 minus R. Well, we just found out what R was. It's 1.5. See? 1.5 right there. So 1.5. And we need to raise it to the n power, but here's the problem. We don't know what n is. See, if we were to count and we said, well, you're A1 and you're A2 and you're A3, and well, we don't know where this one ended. So what we need to do is grab our calculator again and figure out what we had to do to get to that one. Right there. So let's start all over. Be careful that you're counting correctly. I know I'm not trying to insult your intelligence here about counting, but let's be realistic. It's easy to miscount when you're doing these things. That is number 1. I'm going to hit enter. That is A1. Multiply by 1.5. That is a 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We're going to stop. Why do we stop? Because what I see on my calculator is the same as that one. And we got to the 11th term that way. So we know that n, in this case, is 11. Oops, wrong color. Should be blue, unless you want to make it red. Alright, 1 minus 1.5 is on the bottom, and we'll type that in the calculator. So here we go. Type it in the calculator. 128, parentheses, 1 minus 1.5 to the 11th power divided by 1 minus 1.5. There we go. We just added that together. We're not going to round that one off. I mean, we normally round to 2 decimal places. If you want to make it 0.38, I'm okay with that. But, you know, it truncates. In other words, it ends. 21,887.375, because it ends in a reasonable amount. We'll just put that. There we go. Okay. For the next one, again, we're kind of in the same situation where we need to figure out what the next term or what the last term is, like how many terms it takes us to get there, like when we count it. So we start with, obviously, 10. So if you wanted to, you could say, well, hey, you're A1 and you're A2 and you're A3, but you're A, what? Who knows what you are? So we're not quite sure what that is. So here's what we do know. We do know we're adding together a bunch of stuff. We do know it's finite because it ends, and we also know, we just figured it out in our head, it's geometric. Let's be realistic. If you triple that, then you can keep tripling. You're obviously not adding 20, then adding, well, you know, adding 20 to 30 doesn't get you here. So this one is geometric. Can I save you some trouble? Probably shouldn't tell you this. On this sheet, pretty much everything is geometric, because that's the point of it. That's the title of the lesson. Alright, let's start filling these things in. We know what A1 is. We know what R is. What is R? R is what you multiply by every time, so what are we multiplying by every time? Oh, it's 3. Don't be like, where'd that 3 come from? You know where that 3 came from. 30 divided by 10 gave you 3. Okay. Oop, calculator's making funny noises. Sorry about that. I don't know if the mic picked it up, but there it was. So you wouldn't think it was me. There's your first term. Why do we type it in? It's fun. There we go. First term. Multiply by 3. Second term. Don't lose count here. This will throw the whole thing off if you lose count. And that's the reason I typed the first term. So 1, first term, second term, third term, 4, 5, 6, 7. Going to stop when we get there. That's number 7. 8, 9, 10. Oh, found it. That's number 10. That's number 10. Why are we putting it there? Because that's n. We want to know how many terms it is. So that's a 10 right there. So that doesn't look like a 10, does it? Well, it's a 10. 1 minus 3 is on the bottom. We're going to type that in. You know what I'm going to do? Whatever I want to do, that's what I'm going to do. No. 10, 1 minus 3 to the 10th divided by, let's be realistic, you know what 1 minus 3 is. There we go, negative 2. And there's our answer. 295,240. There we go. We just found that one. Now let's speed this thing up just a little bit. And this is going to be kind of fun. You're going to like this. We are adding together a finite number of things, and it indeed is geometric. But this one looks different. It's the summation notation. Summation meaning we're adding. That is sigma, Greek letter sigma, in case you didn't get that memo the other day. So we're going to add all this stuff together. So what we need to do is write down a formula. Fill in everything we need to know. R to the n, that's the n over there. 1 minus r on the bottom. Okay, A1. What is A1? Whoa, now. We don't know what it is. Okay, we have two ways of finding it out. I'm going to give you the easy way and the hard way. Let's start with the hard way first. 1/8 times 2 to the, oops, I need the parentheses around, yeah I do. 2 to the, and then n minus 1, so 1 minus 1. What are you doing, Mr. Reader? Well, thanks for asking. If we plug a 1 into this formula, it's going to crank out the first term. Why do we need the first term? Because it's in the formula. It gave us that. That's 1/8. Let's be realistic. You know this. That number right there, if you look on your pink formula sheet, the bottom right, it has the explicit form of a geometric sequence. And in every one of them, as long as you have an n minus 1 as an exponent, that is going to be A1. So looking ahead, that is A1. It'll save you the trouble. So that's the shortcut. Assuming that is an n minus 1 for an exponent. Every now and then somebody will slip one in where it's not. Either way, it's really good to check. If you want to plug a 1 in right there, figure it out. Okay, so 1/8 goes right there. 1 minus r. What is r? Now, if you wanted to waste your time, you could, but you know the formula. That guy right there is r. It's in the formula. Look in the explicit formula on your formula sheet. That r is tucked away right in there. It's a 2. We're going to raise it to the how many? How many terms are we adding? We're adding everything from 1 to 18. That's what summation notation means. So we're going to go up to the 18th power. And then 1 minus 2 on the bottom. Okay, here goes. 1/8. 1 minus 2 to the 18th power divided by 1 minus 2. Let's save ourselves the trouble. 1 minus 2 is negative 1. There it is. Write it as a decimal too. Makes it sound interesting, doesn't it? 3,277.875. Okay, there we go. We found it. Now the next one's very similar. At this point, we're just kind of practicing our skills. If you want to, I actually challenge you to do this. Mute the video. My voice is probably getting annoying to you anyway. Mute the video. Do it on your own. Keep an eye open on the video. Make sure you're kind of following along okay and you know what you're doing. I'm going to explain it if you need to hear it again, but I'm going to go kind of fast. So try this one on your own. Seriously, mute it if you need to. Here we go. 1 minus r to the n over 1 minus r. Everything you need is built into this formula. This guy right here is A1. This guy right here, it's a guy, 3/4 is R. Okay, so 6, 5, 5, 3, 6 times 1 minus 3/4, and we're going to raise 3/4 to the n power. This one is going to get a little tricky. We have 10 things we're going to be adding, so we're going to raise it to the 10th power. The bottom is 1 minus 3/4. Okay, fractions are going to get a little crazy here. That one needs to be there, and because this is a fraction to an exponent, we're going to put parentheses around that in the calculator, unless you do a decimal. If you do 0.75, that'll work as well. Here we go. 65536, 1 minus 3/4 collectively, parentheses, to the 10th power divided by 1 minus 3/4. That one doesn't need to be in parentheses because it's not getting raised to a power. The calculator knows the order of operations. There we go, we got it. $247,381.75. There we go. We're about to flip it over to the back side. Pause it if you need to. I'm going to go fast. There are 2 more problems. We are going to do this one so super duper quickly. It's going to make you dizzy. This is going to be A1 times 1 minus R to the n power. In this case, we're going from 1 to 5. That would be n right there. All divided by 1 minus 2/3. We got this. Oops, I messed up. Instead of n, I should have a 5. My bad, there. Change it to a 5, you'd never know. (81 halves). 1 minus parentheses 2/3, raise it to the 5th power. Divided by 1 minus 2/3. There we go, 105.5. Okay, last problem before we stop this video. This part right here is going to go into some infinite sums, and we're going to do that one in a separate video, just to kind of break it up a little bit, break the monotony. This one is not summation notation. So the problem is we don't know what n is here. So it's a sub what? I don't know. It is geometric. Wonder what we're dividing by every time. Or, I'm sorry, multiplying by every time. Let's find out. If we need to know what r is, we take 1/9 and divide it by 1/3. And in so doing, parentheses around every important fraction, meaning here, here. 1/9 divided by 1/3 gives us that. Now don't round that off. You know what that is. That's a third, folks. 0.3 repeating is 1/3. You know this. And it kind of makes sense. We're multiplying by 1/3 every time. That means multiply the top by 1, which is why it stays. Multiply the bottom by 3, which is why it triples every time. So there we go. We got r is a third. And now we're going to add them together. So the sum of the first n terms, don't even know what n is yet, but that's okay. A1, 1 minus r to the n over 1 minus r. If at this point you want to mute me and do it on your own, you will not offend me at all. Actually, I'd rather you would. That way I'll know you know what you're doing. 1/3, 1 minus r. Now, just because we need that, you know what I just noticed is bugging me? I should have put parentheses right there. I did in the calculator, so my answer is still right. Just want to throw that out. Throwing that in there. Okay, raising it to the what? I don't know. 1 minus 1/3 there. See, here's the thing. We've left off a number. We don't know what n is, but we're about to find it. 1/3 is our first term. We're going to turn it into a fraction. In case you never got this memo, hit math. Enter a couple times. There you go. It's a third. If we multiply it by 1/3 and turn it into a fraction, let's start counting. We know what we're doing. That was a 1. This is a 2. Enter again a 3. 4, 5, 6, 7, 8, 9. And I'm not sure if that's what we're looking for or not. That's okay. Here's what we're looking for. 1 divided by 59049. We're looking for this one. So let's kind of keep that in mind. If you want to, you can scribble it on the edge of your paper. We're looking for this guy right here. We're looking for 1.69 times 10 to the negative 5. In case you're wondering what in the world that is, that's this one right here. We're looking for it because at some point it's incapable of turning it into a fraction. Calculators can't do everything. Sorry. Wish they could. So we're going to start this process over. Don't you panic. 1/3 is our first one. Turn it to a fraction if you want to, but at some point we're not going to be able to get a fraction, just like you saw. That's a 1. That's a 2. A 3. 4. 5. 6. 7. 8. 9. 10. Oh, found it. And I just want to prove a point. If you tried to turn it into a fraction, it wouldn't go. Sometimes it doesn't. All right. We just found out it was number 10 by counting. Make sure you counted correctly. Boy, I sure hope I did. By the way, there's an algebraic way of figuring it out. It involves logarithms. We will probably discuss it later in the semester. We'll definitely discuss logarithms later in the semester, though. Oops. There we go. Oh, 0.499999. What does that round to? I'm going somewhere with this. I know you're wanting to be like, oh, that's a half. It is a half. It rounds to a half. And normally I would tell you to round to 2 decimal places, but because I'm going somewhere fantastic with this, I'm going to put every bit of that because I want you to see how awfully close to a half that is. That's so close to a half it's dangerous. It's really, really close to 0.5. This is a finite sum. If we were to carry this out infinitely, this would go to a half, which will lead us to this piece. This is the next video and it deals with infinite sums.